Welcome back to the Foundation in C# course. We are currently in Module 6, and this lesson, we're going to be talking about method overriding. All right, so there's two words that are pretty close, override and overload. Overriding is what we're covering right now. We'll cover overloading after our mini project, so in a couple lessons. But let's talk about overriding. So let's open up Visual Studio and come here and create a new project. Console application, and we'll call this the method overriding demo and the method overriding demo app. And I actually have a project already named that, so I'm just going to say override for these. Method override demo and method override app. And I'm going to create a console.readline at the end. And now let's create a quick class here. So public class person model. And we'll have a, prop. Prop string first name. Prop string last name, and prop string email. So if I create a person up here, person model, person equals new person model, and let's actually fill that in. So let's do our curly braces here, like so. And then inside the curly braces, we'll have first name equals Tim, and last name equals Corey, and email equals tim@imtimcorey.com. So there we go. There's our person model. If I were to say console WriteLine person, so I pass in the person object to the WriteLine, what do you think it's going to print there? Well, we're going to find out. I'm going to run this, and it says method override demo.person model. How bland. So why is that? Well, that comes back to how WriteLine works. WriteLine right now is taking this in and saying, well, it's not a string already, but I know that every object in the system has, at the end, as a part of it, toString. Okay, that's kind of the base class for all of these classes. Hash code. And that's a little more complex than we need to get into today. But toString, fairly simple. So I hit tab, and it says, okay, here's the signature line for toString, which is just simple. It's just return string and no parameters, and the name is toString. Now we also have this option here of return base.toString. Base.toString is a call to the parent object's toString method. So when you say base, that's saying, hey, go up and find where this is and call that object's toString method. So instead of doing that, we don't want that. what we want to do is we'll still return, but we'll return a string interpolation. And in here, we can just say first name and last name. So instead of doing what it was doing in toString, it now does something different. Now if we call the same code, we haven't changed this code up here. We actually took the toString off, but it's calling it behind the scenes. Let's run this. And now it says Tim Corey. That's because the toString is now calling this toString because it's a person model. So that's how we can override somebody else's method. And by override, what we're saying is we're replacing the value that was there, or the method that was there, with a new method. Now this mostly makes sense with methods. If you have a auto property like these, it doesn't make a whole lot of sense. But if you have a full property with a full get and set, maybe it does make sense. But for the most part, we concentrate on methods. So let's do this. Let's move this out to its own class. And now let's create a couple of employee style classes. So let's create public class employee. And we can inherit from person. I think that makes sense. Employee model. And in here, we're going to have the value for this is the hourly rate that the employee gets paid. And then we're going to have a method that's going to return the amount they should be paid. So let's call this get paycheck amount. And we'll pass in the hours worked. Now we're going to assume that all employees are hourly employees. So in this case, what we do is we would return the at the next paycheck. But notice if we call the get paycheck amount, but it's a commission employee, it's just going to do the hourly rate times hours worked. It has nothing to do with commission amount. And that doesn't really work for commission-based employees. So instead, what we want to do is we want to do an override of this method. So we'd say public override, and notice that method's not there. Well, why isn't it there? Because we haven't marked it as being able to be overridden. We have to say, yes, this can be overridden by saying virtual. And now when I do my override, I have the ability to override the get paycheck amount. And just like before, it says return base.getPaycheckAmount, which is going to call this method up here and get this value. But that's not the end of the story for us. What we can do instead is we can say decimal initial pay equals, and then we can return initial pay plus the commission amount. You see what I did there? I used this already existing formula and said, yeah, that works for now. I can start with that. That's my initial pay, but I still have the commission to deal with. So let's just add that to the result of this call. I could have just put this call down here and made it one step, and that's fine. This allows you to break it apart and see the two pieces. So now, if I have a commission-based employee, they'll get their commission as well as their hourly rate, whereas a regular employee just gets their hourly rate. Now let's take this up another notch. So let's do this. We're going to move these over to their own classes. We're going to start over with a different setup. Let's create a public abstract class. We're going to call this class car. And a car has a few features that are similar on every vehicle. One of them is it should start. So public void start car. That's the same on pretty much every car, but just in case it's not, I'm going to say it's a virtual. So in general, we're going to start the car by turn key and start. Okay, that's our placeholder for actually starting the car. Well, we also have the idea of setting the clock radio. So I want a method that sets the clock on the radio to the right time. The problem is every car I've ever been in seems to have a different way of doing it. So it doesn't really make sense to, in our abstract class, to have this ability to do a base method call that's probably wrong because every class, every car, like I said, is different. Therefore, instead of actually putting the method body, what I'm going to do is say public abstract void, and the method's going to be called set clock. Okay? It's a little different. It actually looks a lot like an interface. And this is where those two worlds kind of combine. An abstract class, like I said, some people confuse it with an interface. And this is one of the reasons why. Is because they see this and go, oh, that just means you're just defining it's going to have this. And yeah, you kind of are. But another way, we're allowing this abstract class to force this. Now, could we have done this in interface? Why, yes, we could have. So it's a matter of, do you want it in the interface or do you want it in the abstract class? There's not a ton of benefits one versus the other. The biggest one that I've seen is you can make this something besides public. You can make it internal. Oops, not interface. Internal instead of public. You can't do that with a interface. With interfaces, everything is public. So that's one of the benefits. But what this forces all subclasses to do is when we say public class Corolla and say inherits from car, it's going to say, no, I don't. I have to implement that method. Well, there we go. Now I've implemented that method. Now in this case, it makes more sense to make it public. So that should be public as well. But public override void set clock. So it's set up the same exact way. It's just that in our abstract class, it has not been defined with a method body. So now here we're going to say fiddle with the Corolla clock, because I've never found one that's really clear. All right, so there we go. Set clock. And if we leave this alone because Corollas just start like any other car, we're good to go. But now if we come down here and say public class Tesla, which is also a car, and we have to have that override for our set clock, and just say it sets itself. Okay? Because it just sets itself from the satellite, I'm assuming. But Teslas probably also don't start by just turning a key. So let's public override the start car method. And instead of doing this, they're going to think about your destination. And all of a sudden it turns on. Okay, so that's the start car method. So these right here, these base classes, or these base methods that are in our base class, typically you put the code in here if it's common and if it's not going to be overridden all the time. If it's going to be overridden all the time, you either should be thinking about a method signature like this abstract method, or you should be thinking about an interface. One versus the other is going to depend on your situation. The thing with an interface is you either have to also specify start car in that interface, or you need to live without the ability to start the car directly. You have to cast this in order to start the car. So those are the question marks you have to work through, one versus the other, but both are possibilities. If you want to change the type besides public, you have to do an abstract method instead. Either way, if you're always going to be changing it, it's either abstract method or an interface. Whereas if you're going to change it sometimes, but not, more often than not, you're not going to change it, then the virtual method is the way to go. And then you can override it as needed. Oops, right down here. Also, don't forget that you can use that base dot, which we did over here in our employee model. Commissionable employee, where we use that base call to call our parents method of this and have it then return the value, and then we can use that for something else. So you can still call this. One of the ways this might be useful is if in your, let's just say, constructor, you set up a connection to the database, and then you override that in your child class. And so you have a constructor, and you want to override the constructor of our base class. Well, you still want that's not something you can really put in the base class. Because even though most vehicles have it, what about the ones that don't? If I had the option to set my clock in my beat up old pickup truck that doesn't have a clock, I'd start looking around for where the clock is, right? So we don't want to have that option here where you're going to then throw an exception saying, hey, that didn't work, or whether we're going to print a message that says, I didn't really set a clock, or have nothing happen, which would be the worst. Because if nothing happens, you think it worked. And so you're calling this method and assuming things are happening when nothing is happening behind the scenes. So try not to have methods that don't have an implementation in every class. That's true for interfaces as well. So don't create an interface where you can't really do all of the things in the interface. That contract says you'll do all those things. Follow the contract. Don't cheat it. All right. With that being said, let's move our classes over. So let's do our control dot. To move our 3 classes into their files. Make sure we don't have any extra classes. We do not. We're all good. Now, let's move on to our tip for today, which is if you're overriding every method, maybe you just need an interface. So if you have a base class and all you do is override everything, then that's not really a base class. That's just a need for an interface. Just make it an interface. It's a whole lot lighter and it frees you up for other inheritance if you need it. So your homework for today is to create a person class and override the toString like we did and make it return the user's first name and last name, just like we did. So just don't look back at the example. I want you to do it again, but get comfortable with that overriding the method. So override the toString. If you get comfortable with that, then add a method to the person class that you then override in a, let's say, employee class, which inherits from person. Okay? So try and use what we've learned, maybe do the same exact examples if you need to, or tweak them a little bit, but just try to look back so you make sure you have this in your brain. Now, if you have to look back, that's not a bad thing. It just means you need to practice a little more. And this isn't about memorization. This is about comfort level with actually doing it. For these things, these topics right now, for the most part, they are something that by the time that you're more advanced, you'll have these down. Some of the ones you won't have down are the ones that you're not going to use that often. So, for example, the access modifiers from a couple lessons ago. Those, it's great to have a cheat sheet somewhere. And I keep that cheat sheet handy because I don't always remember, is it protected internal abstract override? I don't remember. So you got to figure out, okay, what's the range of all these different things to say, oh, I want internal, or oh, I want protected, or I want, of course, private. So it's not about memorization necessarily, but it is about making sure that you're comfortable with these topics. So if you can do it without looking back, that's great. If you have to look back a little bit, sure, do that. But then do it again. See if you can get to that point where you're not looking back. Once you're done with that, go ahead and move on to the next lesson.